Hi, you're with Sam Higgins and Scott Stewart on LonghausTV's The Research Channel. Now, Scott, one of your first analyst events that you went to was a pretty large Juniper product announcement in San Francisco a couple of weeks ago. We've heard a lot from Juniper in the last kind of 18 months, 2 years. We've done a number of episodes on Research Channel around what Juniper have been doing in terms of both their entry into the enterprise market and also kind of how they view the whole transformation of the network environment. They often talk to us about the kind of current state of play in the network environment, and then I understand that at this event they were talking about their new QFABRIC solution. So maybe let's start with Juniper's view on the problems or the current shape of the network, and then tell us a little bit about what they had to say about their new QFABRIC offering.
Yeah, absolutely. Sam, they talked a lot about Ethernet and that its days are numbered, that it's actually reaching a limitation, and that it was in effect holding back modern day computing, so that it's been good for a while, the topologies have been good around data centers, but something new's needed, and particularly with cloud computing and the pressure that's placing on data center and the need for scale and the need for better performance. And so they were presenting that really, the Ethernet itself is a tired technology and reaching its end of life.
It's interesting, isn't it? Because if I cast my mind back, and you'll recall this yourself in your early career, the big debate about Ethernet versus token ring and which was the better network technology. So are Juniper really saying that we're actually reaching a point now where we're coming to a point in terms of the industry's evolution where we're going to have another of these kinds of debates? Is that what they were saying? Yeah,
absolutely. And they talked about new technologies or new enhancements or plugins or all sort of new things like such as Trill, being created or invented to try and resolve some of the performance issues of a packet moving around a data center, and the fact that packet loss is one of the biggest challenges of a data center sort of operation. And they actually said that we are prepared to basically start with a blank sheet of paper.
Wow. Okay.
So instead of trying to look at the current technology and work out how to solve problems, how to get around it, they said let's wipe the sheet clean and start again, and that's a sort of big risk today to do that, and that took in this case they're saying that $100 million investment, million man hours, 125 patents later, and they came up with QFABRIC.
It's pretty interesting, isn't it? Because we've seen a lot of this kind of big R&D investments from organisations over the last few years. If I think back to some of the investments that Oracle have made in re-architecting their whole product platform, Larry Ellison's announcement of Fusion 6 or 7 years ago, hundreds of millions of dollars invested, many man hours. It's the same here. So it's really interesting that there are some pretty big bets being made by companies like Juniper. Now, one of the issues that you and I spoke about in regards to network topology is this kind of up and down versus east-west kind of topology, where all of the intelligence in a data center is built into the core switch. Now, given that Juniper traditionally sell all of those, switches and routers and all that sort of thing, are we talking about a situation where they're going to do themselves out of a job? What is this new technology look like, and how is it different than to what we've seen before?
Yeah, look, that's an excellent point. I mean, Juniper have done a lot of work in sort of flattening out the data center for a lot of their customers already. So a lot of their previous products have actually kind of reduced it down to 3 layers. So you have the top of rack switches, the aggregating switches, and the core switches, and of course that's where the intelligence is and all the expense is, of course, as well.
Yeah, that's right.
And to scale a data center out, you need to add lots of more nodes to it, and therefore, as you go down that tree, they become dumber, if you like. They dumb it out. So in a data center, 75% of the traffic actually doesn't go north and south. It actually wants to get over to this side of the data center.
Right.
So whether and so they're finding that for that to happen, a packet has to have about 5 network hops. So I liken it to boarding a plane. They check your boarding pass and say, oh yeah, you're in that seat, and you keep getting checked as you go through, and it sort of makes the whole process a lot longer. So perhaps not the best analogy, but it's sort of.
But none of us want to go via. No one wants to go to Melbourne via Sydney, right? We all want to go direct to Melbourne. That's how we prefer to fly.
That's right. So they're presenting that something really different needs to happen, and with QFABRIC, what they're saying is that they can read a packet once. so that every device can see every other device in the data center, completely sort of flatten out a data center, and the intelligence is at the edge of the data center. So it reads the packet once and says, well, I know exactly where you need to go, and off it goes.
Yeah.
So it actually, in effect, turns a data center into a complete single switch. So instead of having the kind of the core, which is the intelligence and where the expense is, and having to try and deal with that scale, basically the intelligence is as you arrive and read the packet once, and off it goes.
Off it goes. So in some ways that's very different, isn't it? Because I mean, even the name, right? We talk about core switches, and it implies that they're at the centre of something.
Yes.
So effectively, this new approach that Juniper are trying to do is to take that device intelligence and distribute it around to every device that could possibly be interacting.
Yes.
And I'm assuming what they're trying to achieve in regards to cloud then is the fact that we can potentially end up with a lot of issues in terms of routing traffic around the cloud. Because once we start to distribute all of our computing services within an enterprise across different cloud providers, then not only have I got the problem of multiple hops inside my data center, but now we're talking about those 5 hops between me and another service that my enterprise is using, and then maybe another set over here. And if I'm trying to integrate those 2 cloud services together, then I'm making this routing problem, this hopping around, exponentially worse, presumably. So they're trying to attack that. Did you get any feel from Juniper on, how real this kind of thing was from a performance perspective? We've heard a lot about things like InfiniBand, and we see InfiniBand being used in certainly in single device arrangements, like Cisco's kind of UCS technology. We see it in the way in which Oracle have done their Exalogic and Exadata machines using InfiniBand. So how does this kind of approach compare to that from a performance perspective?
Yeah, there was a presentation there from Berkeley Labs who actually have taken QFabric through its paces in a very sort of serious scientific sort of approach. And I actually spoke to this gentleman at the end of the launch, and had a very good discussion, and it was quite interesting because basically what he was saying was that in the academic community, they have been dealing with fabric for 15 years. They've had to invent their own fabric to get outside of the bounds of Ethernet, so that they can run their supercomputers and their algorithms and the kind of heavy-duty computing that they need to do.
Yeah, because they would do a lot of clustering, right?
Absolutely.
And they'd be wanting to exploit. I mean, in the old days, high-performance computing in that kind of environment would have been buy a big box.
That's right.
More recently, it's been kind of, they've been those scientific people have been the fathers, if you like, of grid computing.
That's right.
And using commodity hardware to achieve that. Okay, so in the past, just so I've got that clear, in the past what they would have done is effectively built their own network protocols to join them together. Okay, right.
So they are saying, for instance, that for them, QFabric is probably not going to change their world because they already have their own sort of established fabrics. But the significance is that it will provide greater access to more people and more research by running it over Ethernet. And so they tested that. So QFabric, out of the box, over Ethernet, achieved 90% benchmark against their own supercomputer fabric, that they were running.
Wow.
And he also made the comment that was with all of the overhead that comes with TCP/IP and all that they hadn't stripped that out. So out of the box, just running it, they were able to achieve a 90% benchmark. So I said, well, what effect does that really have? And he said, well, there is a queue up of research that is waiting for access to this sort of level of power, supercomputer power, so processing power. And it will basically allow a lot more people to have access to a lot more faster computer with better performance. Because they were talking that the tests that they had seen showed that edge to edge was under 5 microseconds. So that's equivalent to a 10 times increase in performance.
Yeah, so it's pretty significant. Yeah, and when we think about the potential distribution of cloud services, we've talked about things like, well, people might use infrastructure as a service, but ultimately the real business value in cloud is in software as a service. And chances are then your software as a service providers aren't all going to be in the same data center.
No, that's right.
Then having the ability effectively, I suppose, to have a fabric across your cloud providers so that you don't have the latency issues that people do worry about. I mean, in our early cloud research, some of the barriers to adoption of cloud computing amongst security and governance were things like network latency. So this would presumably go to that very problem.
Also, another thing that came out of the whole QFabric launch and the statistics around the benchmarking and the testing was power reduction. So it was a 77% reduction in power in a data center using QFabric. There was a 90% less footprint and about 30% or 26%, I think it was, less devices.
Yeah, which is important if we're trying to strive for kind of that, lean, mean and green.
That's right. So there has been a lot of talk, hasn't there, about, green IT, where did it go? And we moved on to cloud, but I don't think it actually went anywhere. I think what it was is it's sort of been, it's still out there, and I think it's coming back. I think the whole green IT and the carbon sort of footprint debate, and it was kind of interesting that this sort of really started to sort of raise that issue, or that requirement around green IT.
We do see that, you're right, don't we? We often see it attached to other strategies, so it's good to know that green IT can not only be something that you can apply as I suppose a complementary strategy to things like server rationalisation, server consolidation, but now we're seeing some of this virtualisation and some of this rationalisation in network devices actually offering us some benefits. So in terms of our enterprise clients and thinking about kind of bottom line recommendations, thinking about the time you spent with Juniper and what we've discussed, what do you think would be the kind of things that some of our larger enterprise customers need to start to think about as this type of technology kind of comes on the market?
I think that what they need to think about is certainly have a look at some of the things that Juniper is saying about the reduced footprint and the performance and the scalability. The QFabric set, if you like, it comes in 3 components, and the first of these is available now. So that's the top of the rack switch, and that on its own, from what I can understand, is a very high performance unit at a very low cost. So their strategy is quite. I found it quite interesting that basically you can actually migrate to a QFabric, if you like, environment simply by starting to adding these nodes or these switches. And as you do that, you'll experience improvement in performance and scale and start to see some of the low latency and low jitter and all those kind of things, benefits. But they do make the point that you don't really have QFabric until you have all 3 components in play. So unfortunately, those 3 components aren't available today, but the first of the 3 is, and it probably does suit a lot of clients who might consider, putting some of these components in to test for themselves the performance, and all the other things you test when you're using a vendor around service and support, etc., and basically start to build a migration strategy, perhaps, towards implementing QFabric.
Sounds like a good strategy. Hi, you're with Sam Higgins and Scott Stewart on LonghausTV's The Research Channel. Now, Scott, one of your first analyst events that you went to was pretty Juniper's view on the problems or the current shape of the network, and then tell us a little bit about what they had to say about their new QFabric offering.
Yeah, absolutely. Sam, they talked a lot about Ethernet and that its days are numbered, that it's actually reaching a limitation, and that it was in effect holding back modern day computing, so that it's been good for a while, the topologies have been good around data centers, but something new's needed, and particularly with cloud computing and the pressure that's...
The industry's evolution, where we're going to have another of these kinds of debates, is that what they were saying?
Yeah, absolutely, and they talked about new technologies or new enhancements or plugins or all sort of new things like such as Trill, being created or invented to try and resolve some of the performance issues of a packet moving around a data center, and the fact that packet loss is one of the biggest challenges of a data center sort of operation. And they
large Juniper product announcement in San Francisco a couple of weeks ago. We've heard a lot from Juniper in the last kind of 18 months, 2 years. We've done a number of episodes on Research Channel around what Juniper have been doing in terms of both their entry into the enterprise market and also kind of how they view the whole transformation of the network environment. They often talk to us about the kind of current state of play in the network environment, and then I understand that at this event they were talking about their new QFABRIC solution. So maybe let's start with
basing on data center and the need for scale and the need for better performance. And so they were presenting that really, the Ethernet itself is a tired technology reaching its end of life.
It's interesting, isn't it? Because if I cast my mind back, and you'll recall this yourself in your early career, the big debate about Ethernet versus token ring and which was the better network technology. So are Juniper really saying that we're actually reaching a point now where we're coming to a point in terms of